Hello everyone, this is Janer from Sweden, from Alp Electronics. This is the second video of the ESP32 Smart Screen Design series. So we will be actually designing the schematic for it. So for those who didn't watch, actually, we had the first video that's already published. You can go and just watch it. It's available in YouTube in our channel. But let's do a sound check and video check before we start. If everything is okay, so then we can continue. Please just acknowledge those followers if you can hear very well, and then if you can see me very well as well. By the way, it's very cold in Sweden now. It's like -4 or -5, I guess. It was frozen on the ground actually. I know Turkey had a lot of troubles as well. I have seen it in the news. Can you guys just verify if you can hear it well actually, then we can start. Okay, I can increase the volume a little bit. Yes. So what about now? Is it better? If it is better or if it is hearable, let's start. But otherwise, just let me know. Okay. In the first video, I had a block diagram, but that was not complete yet. So today, actually, I had drawn this block diagram again to make it more clear. So what we want to do is actually like this, something like this. To design a circuit, you need to actually approach systematically. So you need to basically do this block diagram actually before you do anything. Otherwise, you're gonna be lost. So to be able to actually design a block diagram, you should know the system very well, and you should know the components, and like how you should separate like the components, boards, and so on. That's an important thing actually, and that's not just like how can I say, like it will take some time actually for you to develop this actually knowledge. But it's like for now it's pretty easy, but there are of course difficult circuits like where we can, for example, do lots of analog processing and so much. So at the moment we have this 4-inch square touch LCD, which is available on our actually website. If you haven't checked it, you can go and check it. So as a main processor, we have this ESP32-S3. Probably you know it, but it has Wi-Fi and Bluetooth, and you can have it simultaneously. It has this coexistence module. And then we are planning to have actually some sensors. One is accelerometer, one is like temperature, humidity, and the air quality sensor. This is just one single device actually from Bosch. And then we want to have this ambient light sensor, which is called here like as light only, and then that will just transfer the data through ADC. Of course, it's not transferring data, just to emphasizing it, but we're gonna measure its voltage drop with the ADC from ESP32, and then all these sensors will be communicated through I2C, and then I will use this I2C actually to get data from the LCD touch screen, because the touch screen is controlled by the I2C. And then we have this QWIC connector, this SparkFun one. And then it's good to have a micro SD card, because you can like store your let's say images and so on, or any other data. Thank you so much, Maker Moki. I forgot your name. Sorry. Uh, Please, you can follow his Instagram, guys. He's a really nice guy. He's posting a lot of electronic videos. He's making lots of good stuff. And then we will have a microcontroller, another microcontroller. Actually, the purpose here is to use this as a GPIO extender. because normal I2C GPIO extender is like around like $0.5, like 50 cents or something, and this one is like 70, 60 cents. So we can have actually more feature in this microcontroller, but the disadvantage is that you need to program this one as well. Of course, we will program this one and then just ship it with the programmed with the program in it. And then I'm thinking to add a docking station or a docking connector from the available pins left, if there is any left, but we're gonna see it. And then we should have one battery. We have actually in stock at the moment for 4.2 volt LiPo. It's like 1 ampere milliampere per hour. And then there should be USB Type C. So there should be a trick here, because whenever the USB Type C is connected, it should charge the battery, and then the circuit should get its power from USB Type C. Basically like this. So that's why we need to have a power selector, and then we will design the power selector now. So let's start from the power selector, and then this is Altium. So we have the project files here, and then we have had these details I explained in the last video. So this power section is actually from our Raspberry Pi board. We're gonna use the same board, same circuit, because I have already designed it actually. But there should be some adjustments, so we need to check that later. But let me explain this circuit actually first. Just let me drag this a bit. Yeah, so we have the power input from USB Type-C, and it's called USB VCC. So that USB VCC comes to this point. Just ignore this one. This is not installed. This is our actually custom module. We have made it. It's just like for a current measurement, a smart current measurement. But anyway, so this is just already shorted actually. So you can omit this one. So it's something like this. And then the power actually passes through, and then it goes to 3.3 LDO. So yes, the USB actually powers the LDO, and then at the same time it should actually just charge the battery. So how we do that? So this is the charger. So the voltage in is here. So you get the power, and then the battery is connected here, and then this is the battery actually. You should see this as a battery because there is the protection. This protection actually just separates the ground from the battery in case there is any problem, like overcharge detection, overcharge release voltage, over discharge detection voltage, over discharge release voltage, and so on. So this is a nice one. Usually this one is actually embedded in the battery. They already assemble it, but in case you don't have this protection, there will be a trouble. So that's why we have to put it. I just put it actually like as a like double security to just make sure that everything is okay. And then in this charger, we have this status output. We can just check it is actually a data sheet. I opened it already. Yes, this is the data sheet. So we have this like very classical 4054 LP. I always actually suggest you to read or check the datasheet before you do anything. Read these pin descriptions whenever you are designing the circuit. It's very important. And the pin we have is like stat1. So let's see stat1. Open drain, charge status output. When the battery is charging, the stat pin is pulled low by an internal N-channel MOSFET. When the charge cycle is completed, the pin is pulled high. Yeah, this is very clear. So we can understand if the battery is charged fully or not. And then I said charge, this pin is also important. Charge current program and charge current monitor pin. So you can actually adjust the resistor here, and then you can change the charging current. Also, it says like charge current monitor pin. The charge current is programmed by connecting a 1% resistor to ground when charging in constant current mode. This pin serves to 1 volt servos to 1 volt. In all modes, the voltage on this pin can be used to measure the charge current using the following formula and so on. And then that detail I checked. What was it? Of course, you should check the other parameters as well, but there is one more thing I want to show you. So programming charge current, and then the charge current out of the battery can be determined at any time by monitoring the iSet pin voltage using the following equation. So it basically says that just measure this point and then use that formula, use this formula, and then you will be able to find this battery current, charging current. And the formula here is actually simple because you measure this one, the V, you know the R, and then just do the calculation in the software. And then, let's continue. Yeah, so this is the battery. I told you that you should see this as a battery pack. In the battery pack, we have these two connector options. Actually, just let me show you fastly. Sorry. You can go and check. Actually, this board is available and it's on sale at the moment. We have it. So this is one actually very popular one, but we don't use this one. We use this one because this is really small, and then you can put a case. And then the batteries actually have this male connector for this one. Anyway, yes. So yes, that's why we have these two different options, but one of them is not installed or assembled. So you should just check this one. Yes, this one is not assembled by default. And then there is one thing actually, how we do this power selection. So it is this and this little guy here. So this one is just a load switch, but let's check it is actually specifications. And that is from LCSC as well. Yeah. Yeah, this is a load switch, but there was one thing here I just wanted to show you. Yeah. The good thing here is that actually when the power is actually like flowing through from V in to V out, you can enable or disable it. And there is the current limit. You can set it. But the good thing is that actually there is no actually reverse current actually flowing from V out to V in. In some load switches, it actually flows. So this is a problem. But in this case, we don't want it. That's why this is actually specifically chosen for this purpose. Why? Because the USB VCC is connected here. Okay. So if this one actually comes here, and then if it actually passes in the reverse direction, so it would power the battery directly, and the battery should only be powered from this one actually, because in this case it can charge the battery, so we don't want this one. So we want to actually limit that USB VCC cannot go and then be connected to this battery pin basically. Okay, and then so how do we enable this one and disable it? So it's here. This is just an N-channel actually MOSFET. When we have this USB V bus, okay, here, we just actually enable this one. And when we enable it, this battery enable will be 0. When it's 0, this one is disabled actually. So we disable it, and then there is no actually current flowing from V in to V out. So and then when there is no V bus, which means this is actually like grounded, when it is grounded for the MOSFET N channel, and as you can understand that this is actually turned off, this MOSFET, and then the power on the battery will come here, and then this battery enable will be just will become 1, and then this will be enabled. In this case, the battery actually will power the V out, and then it will go to LDO. But there is one more trick here. Do you want, if you just leave it like this, if it was just a direct connection from USB VCC here, there would be one problem. And then the battery would actually supply power to the USB V bus. By putting this diode, you actually block this reverse current actually here as well. So it's a little bit tricky, but you should be able to follow it. So this, when you power actually the LDO from battery, and this line is like anymore it's battery, when there is no USB VCC, or when the USB is not connected. So, but this is a bit tricky because the other parts is getting like power from USB VCC, and then what you need to do is actually you just need to actually block or limit the reverse current, so there is no voltage on this bus, because this one is just directly connected actually before the diode. And this has another advantage, so it can actually act as a protection, reverse polarity protection, because if you connect in the wrong direction, but well, if you can't for the USB, but let's say you make a mistake, or you just tie your own cables or solder it. So we just need to copy and paste it to that circuit, but let me get one by one. We have already these components in stock. That is what this is one thing actually. That's why I want to use the same components, not to actually order new ones. Hi everyone. Again, for those newcomers, yes. So let's go to power, and then you see this is still actually not done here, so I need to just cut and just insert in between. But I'm gonna do like this. So I will show you one. I will just not copy one by one, but what I want to do is I want to get the whole circuit. So let me just take like this. Okay, and then come here. Okay, so just this one needs to be here as well, and then we should have these EST protections here somewhere. EST protection is important, as you know. We are human beings, all loaded with this static electricity, and then you need to discharge it before you touch to the device. Well, these devices are hot pluggable. Hot pluggable means that you can actually spontaneously connect any device to the connector, and then it should recognize, and then just it should work. For example, SPI, I2C, UART, they are not hot pluggable because they will not actually understand when you insert that one, unless you actually implement a special circuit. But for this one, you don't need to do anything extra. When you insert the USB, the computer recognizes, because there's a special circuit already for that one. So this is actually set to be hot pluggable. And there are some other actually like standards and connection types actually which is hot pluggable. I think it's PCI as well, so it was something like that. Anyway, so we should have these ones. Yeah, and then so when you touch to the connector, usually actually the pins is actually objected to this electrostatic energy, and then if you don't discharge it or if you don't dissipate it, the pins which is connected to this actually USB will be damaged. So you need to actually that's why protect it by using a TVS diode. Basically, TVS actually suppresses these transitions. But the pins are not same as IC, so I need to just correct it. And this is P, this is N. Altium actually recognizes this P and N suffix, so you need to do this, or you can define your own, but this is just one time thing. You don't need to do it. And this is a differential pair. Actually, I'm defining a differential pair here for the USB. You might know it. The impedance of the traces need to be 90 ohm differentially. and 45 ohms single-ended. So for this one, I want to remove this actually module because we don't have it yet. And then this one, and then no bridge here. And then just do like this, a little bit just. Yes. So this should just work as ESP-LC6 and the TVS diode. What is USB-LC6? What is that one? I don't know. I've never heard it. Yes, it should just work actually like this. But we need to take these USB pins to the ESP32. Don't forget just. And yes, they are here. And then we delete that one. I just put this one. But there is one trick here. As I see, this is connected directly. But let's just go to ESP32. I remember something. It was suggesting actually to connect some series resistors, as I believe. Then we will check the other details too. So I'm gonna show you how. It's usually good to follow this schematic, guys. Well, it suggests like 0 ohm, but I'm sure that it was suggesting something else in other documents. This will improve the signal integrity, but let's check what was it in this one. Yeah, we used 27 ohm. But this is 00402. I'm gonna just, yeah, I'm gonna just put a like 47 ohm like this. In Altium, if you just you have let's say this component, if you just press shift and then drag with your mouse, and then it will just duplicate the part for you. So I'm gonna test this one, guys. So it might be a little bit high, but I'm gonna measure it with the scope if I can. I know that this is USB 1.1, so it's not very fast. Yeah, but I can't know the IC name, right? If it's a ESD protection IC, probably it has just this like TVS is actually just built into it. That's not a trick. Okay, we have done this, and then there is the connection, but just let me put a note here. So just test the series resistors for the USB. This is important actually. I always do this. I always put notes in the design because this is where I usually always check this schematic. And this rest is okay. According to the block diagram, I said that the microcontroller will be connected through either I2C or SPI, but I think I2C is okay because I use the same I2C for these lines already, so it's good to use the same line to reduce the number of IOs actually used. So that's why I'm gonna remove this option. I don't want to do that, and then I can just move it up. So we have just one point. And then yes, we should have this interrupt as well. Yeah, that's okay. And then let's check the power if we missed anything else. No. USB here, yes, protection battery here. But the thing is, I have just copied these ones from there, but I need to change actually these components because they are O4, O2. Like I want to use O6, O3 for this one, for easy manufacturability. So what I do is just you should do the same. If you have a component that you use actually multiple times, just copy and paste it. Because otherwise, if you go and just pick a new component, there will be different BoMs, different MPNs, different components for the same value. And then your bill of material list will not be actually simplified. So what I'm doing is whenever I just place a component, I just actually copy and paste multiple times whenever I want to use it. So I'm gonna do the same. Just get this 10K and then just delete this one. Put that here and then same here. And then same here. And then same here. And then 2K. I don't think I have used 2K actually, so it's in the circuit already. So I'm gonna just check the resistors. So you can just search 2K like this. Yes, it's here, I think. Yeah. Yeah, the 5% would be okay because that's not a like precision circuit. And then as we said that you can actually monitor this pin and then understand the or monitor the charging current. And we want to do that, yes. So what I said. So I just do I said and just put it here because I'm gonna have a port, Altium needs a port. Okay, charge that one, and then this one should be also with the port. So I just put it here, not to forget. And then what else? Let's just continue. Yes, let's just continue. Yeah, 1 ohm. But 1 ohm. Do we have 1 ohm? Or that's a, yeah. Yes, that's a 1 ohm. Is everything okay, guys? Like, is it understandable for you? Do you like it? And then let's check this capacitor. Yeah, this is already 0603, so no need to change it. This one as well. This one is 0402, so I need to change it. So I open the capacitor ceramic. Just 1 micro. Serious. Usually the voltage levels are important, but since this is 3.3, I don't care actually much. So that's why you should check whenever you do it. And the USB VCC in this case can be only up to 5 volt. Well, for the USB PD, it can go up to, I think 28 volt or 48 volt in the new standard. I'm making a new USB PD actually as well. And then that's there. So these ones we need to check. And then just let me get one, yep, of this one. This 100 ohms. And then we need to have this 100 ohms. Yes, it's I think 0402 as well. Yeah, unfortunately. Just let me go to resistors. And then, yep, 100 ohms. Again, 5% is okay, so no need to have a precision here. Yep. So we put it there. Yeah. I think we didn't forget anything. But there is one thing here. As you might notice, I have changed this ground notation to 0 volt because ground actually is a bit misleading. I mean, ground is like usually should be earthing actually. But in electronics world, I don't know why we use ground. Who has started to use? So that's why I'm changing it to 0 volt. So in Altium, what you can do is you can just right click and find similar objects, and then like power object same, and the power ground same, and the text same. And then when you say apply, it should select all of these ground actually. And then okay, and then so it has selected all of these grounds. So we're gonna just change it, power ground to bar, and then the text to 0 volt. You see, I have just changed all of them at once. and then Shift C to just clear the selection. And then yes, just save it. Yes, okay, we have done this, which so I just need to take these two pin. I have taken already these two, but just these two pins to there. But we can actually go to, so we don't need to use these ESP32 because we have already this expander. But let's just use the ADC pin of it and then just monitor these two actually. But I set pin needs to be monitored with an ADC, but this charge is just is enough to actually monitor it with an IO, digital IO, not an ADC. But let me just open the datasheet. The datasheet is here. The footprint we use is LGA20, okay, and the device is this one. And then let's look for the ADC pins, like you see ADC in 0. And then which pins we have it available, like PB1. Let's see if PB1 is capable of doing, yeah, ADC in 9. It's here already. So let me just put it here, but let's do a trick here too. So we need to have a low pass filter, guys. So because you know the voltage might fluctuate or it might be noisy, so you need to actually have a filter whenever you go to the ADC. This is just you know like a very basic rule. And then we have this ground problem here too. You see, there's different grounds, and then it will create a conflict. So I just press Shift and then just select all of them together. I just correct it. And then for the low pass filter, you can, I mean, I know the formula, but just to show you, RC low pass filter, because you need to set the capacitor and the resistance values, the cutoff frequency, and then yep. So where is the FC? Yeah, basically this is the rule, guys. So R and C, you use it. So I'm gonna use something random at the moment. So like 100 nano and 1K. But I remember from somewhere that I've used this one before. But we just need to calculate it again. I'm just looking for 1K. If we have it anywhere. Nope. So I can just here. No. No either. Okay. Just let me put it from the components, and then there should be 1K here. This is just 5% as well, so it should be like this. You know, the input is usually high impedance, and then so that's why it will not affect so much, but it will improve the signal integrity. Yep. So, but there is one thing we just can say that ADC in 9 actually for the programmer, so we can make the life easier. So we can put a note. Usually, or normally it should have this actually pin marking here, and then we could just change it. And then let me just double check it. Yes, it's ADC in 9. This is okay. Yes. And this charge, so we can just put it anywhere. And then yes, let me just connect them too. So what you can do is actually, if you don't want to do it single by single, one by one, so you just can actually drag your mouse from right to the left, and then it's gonna appear as a like green box. Green box means that it will select the place or the object it is touching like this. But if you are just dragging from left to right, it's going to appear as blue. And then it will just select the object if it is covering fully. So this is the trick here. And I'm doing like this, and then just Control C and then Control V. So Control C and then Control V. You see, just one pin is empty at the moment. And then we are deleting this one, yes. Probably that's going to be actually used as well, because we will use the light sensor, and then light sensor can be just put here. Light sensor, yeah, we need to make the light sensor too. Yes, I forgot that one. So the light sensor we select is, where was it? Yes, this one. You know, it's going to be like on the box, the shell, so it's going to be pointed out. It will point out, so it can actually monitor the light, and then we can use it as a light sensor, ambient light sensor. And this is the data sheet. So it just explains in some Chinese and in English. Operating voltage 1 to 10 volt, power dissipation 70 milliwatt. Oops. And yeah, it says 5 volt, and then there should be some type of like example circuit. Yes, it says VDD 5 volt, but I believe we can use 3.3 volt too. So I'm gonna use 3.3, and then we will use RMS, and then just 1 kilo ohm, and then we can just calculate the voltage drop across this resistor, and then we can just determine the light just by calculating it simply. So we will do this one, but we will put a low pass noise elimination here too. But let's first just do the components actually. If we don't have it, I mean, at the moment we can put something like this. We don't have anything, but maybe an LED. So miscellaneous devices you might have. Diode. I'm gonna use just a generic symbol here. Let's see what we have. Yeah, photo maybe. Yeah, it should be something like this. I like this one. Yes. And yeah, the sensors are already here. So this is the light sensor. Just take this name, properties, copy it, and then just put it here. Comment, yes. And then, yeah, in the bill of material, so you can see this one. And then we can delete this one. So it was saying that basically just connect this one, yes, and then connect this one, but we will need to have this 1K, yes. And then just let me just actually the low pass filter should be close to this pin, you know, this is important. And then because you want to filter the noise actually entering to the MCU. So if you leave it just close by to this sensor, so on the way it's gonna keep the noise again, or it will get the noise again. So you just want to do that on the input of the MCU. Okay. So just say that, get that label, and then say just maybe just light or ambient. Sensor, yes. A and B sensor maybe. But let's see if this one available pin has this ADC input. Let me just check it. Normally you should actually take a Excel or something. Actually, you should note these ones. Unfortunately, PA9, right? PA10. No, unfortunately, it doesn't have an ADC. So A7, it has ADC in 7. So maybe we can do that. Yes, we can change the pins. Yes. Just let me do this and just copy it like this. Yes. And then this was ADC 7. Or we can even put a net label actually. It can be visible on the ADC in 7 and then in 9. Yeah, automatically it increments actually. Yep, I think this is a nice one. Yes. So, but so if you want to make it look nicer, so I just suggest you do something like this. I'm gonna just show it. What we can do is we can put a rectangle like this. Sorry. Yeah. And then put some text on it above it. I use actually my company's text font. Sorry. And then this is like temp hum and sensor. So just let me make it a little bit bigger. So do the same here and then lights sensor. Hello, Orion. Yes, and then actually we should do for others as well, but you can follow it. I will do it later, not on the live stream. Uh, yes, we have done the power, we have done the screen, we have the board, and then as we said that we will not use these pins anymore. And then this one TP int, we will not have it anymore. And this one should be connected. And then these pins actually 1, 2, 3, 4, 5 can go out to the docking station. So we should have one more actually connection like this. But we should just say that maybe by the way, I don't like these ports to be here actually. I just like separated like this. So what I'm gonna do is I just Control C and then Control Shift V. It means smart paste and then paste as net labels. Where was it? Yes. Still it's in the memory. Yep. Take it like this. Same for this one. LCD chip select. Yep. I put it here. Oh, there are two more actually empty here too. So we're gonna have a good docking station. So we can put some sound and so on in the docking station. But I'm gonna just name the iOS here like this. So just let me extend this wires. You can do like this as well by simply like dragging all of them. And then just net label again, IO, that just ESP32.io 36. Yeah. 36, 37, 38, 39, 40. Yeah. And then shift select and copy and then just paste. And then what about these two? 47 and 33. Yes, and then shift. Yep, they can go here too. And then Control C, and then let's go to interface. Okay. Yeah, the QWIC connector is here, and then the SD card connection is here, and then 2, 4, 6, 7. We have 7 connection. So let's see what we can use actually as a connector. I need to actually decide it. Maybe offline, not now. But we should have something like 10 pin or like 12 pin, because we might connect the battery and so on as well. Let me do that. Power. Yeah. Yep. So this is the battery output. And USB VCC, because we can supply voltage from outside. Oh, if we want to supply not USB VCC, we need to supply to USB V bus, and then USB V bus needs to go here. Yes. Go to interface. Yes, put these two, and then some ground. So 1, 2, 3, 7, 10. Let's put 2 more like connections, sorry, and 1 more USB V bus to make it like sturdy. Maybe just single V bus is enough. So in total it's gonna be like 13, but yeah, 13, 15 is okay. But let's see if PCIe Express connector is suitable. I forgot to create the footprint for this one. Let me just create it. I'm gonna try to find actually something ready-made. So this is 254, but 3 millimeter. Can I find like 3 millimeter, 3 millimeter LED through all step 3D step file. It's always good to have the 3D step file. I think there are some models LED 3 millimeter, but let's see if we can get something like that cup. Oh, true hole LEDs. Flat top, yes. Oh, this is nice. Like 3 millimeter flat top. Let's see. No, nothing. I don't think this one is suitable too. Do we have anything here? Anyhow, we will need to design it already, I guess, ourselves. Flat top. Flat top. Do we have anything flat top? Flat top, flat top. But let's see if it's gonna be something like this. But let's see if it's available in LCSC. I think we can extract it from there. I don't know. No. It's all normal LEDs. Anyway, I will do it later, or I can design it on my own. So let's go to just if we have any library here. Okay, we have this library. This is not the database library. This is just the PCB library. I'm gonna just put LED 3 millimeter. Okay, and then just make the grid 50 mil, and then it's not visible. Just grid properties, just lines. Yeah. Okay. And then what was the shape? So it is basically saying that the distance, actually the pitch is 2.54, which is 100 mil. So we should have one pin. Oops, we should have just one pin. Diameter should be, I think, 1.3. Usually but I need to check this. Is this, I think we put just a wire, sorry, it should be a pad. And the igniter is 1, and the size, yes, should be round. This should be 1.6 probably, and then this should be 1.6, and the hey, where is the this should be multi-layer. If it is top layer, it means it's SMD, and then it will not show you the hole, basically the pad hole. Yes, the pad hole, but let's check the pad sizes if it suggests anything. It says 0.5. Actually, we should make something like 0.6 or 0.65. Depending on the available drill bit size. And then we don't have to have this big, or maybe 1.1. Yes. And then you can actually watch the top left here. So it shows the distance, like this is 0, 0, and then it goes like 1.27, and then 2.54, and I just click and then place it here. So, and then we can just do a little bit cheating, and then there was this actually, this second pin, it says plus, and then there is this thing here, this top layer, 6 screen, and then we can do the same basically. So arc edge, maybe that one, I'm not sure. Okay, no, it was not that one. We should select the top overlay first. Oops. And then just go to any angle. Oh, no. I need to increase the grid size to something like this, and then no. Yeah, I think yes. Just copy and paste it. Just copy and paste, and just shift. Sorry, space. Maybe it's a little bit more. Yeah, but this is so thin it will not be visible on the PCB, so you need to make it 0.15 or 0.1. And then if you want this plus sign, we can do that one as well. Simply you can do it with lines, actually. I like it. Yes, I rather put it here. Yes, let's see if it is similar. Yep, almost. Yep, and then yes, let's see, top courtyards. So we can put this one. So this just limits where the component is, or if any other component can be placed nearby. Oops. And then top designator. This is important. This should be actually centered. Yes. And the top designator, you just come here and then just add a string designator, which means that the designator, the part number on the schematic will come here actually. But maybe we couldn't select it. Yes, calibrate. And then when we can find the 3D, we can add the 3D actually as well. Atom component outline, but no need at the moment. And atom component centered maybe. Yes. So we need to use this footprint, and then I have created it as LED 3mm, and then just I need to select it. Where is the interf? It was in the sensors. So I need to go here, but I need to check first actually if the pins are matching, because it says that plus is actually the anode is second pin, this one, the cathode is this one. Usually there can be some conflicts, and then you can like connect in the wrong way. So that's why you need to check these connections always first. What I do is I'm gonna just select this one. I'm gonna just go to properties and the pins. I will just actually make this visible. So you see anode is the first pin. So in this case, anode will come here. So we need to actually change them. Either you can change their designator, or you can just swap them like this, whichever is easier in this case. And then we'll just come here, and then I'm gonna just add a footprint here, or you can just select this one and then press edit if it is already there. So LED 3mm, and then I select it, and then I just assign it. Yes, I think we are almost done. The only thing actually left is the connector. Where is it? Yeah, the interface connector. I'm gonna need to check it, you know. But let's briefly check it, and then the stream. But let's see. Let's go connectors. It should probably be like the PCIe connector is an edge connector actually, card edge connectors. And then I'm thinking to use actually the 127 pitch header, but I need to find like board-to-board connectors. Yeah, Mazenin board-to-board connectors, yes. But if I go to Mauser, I think I have that one already like in stock, so I can use that one. That has different actually length, sizes. Maybe you shouldn't see that one. No, it's not here, but it is this one. I can just show it like this. Anyway, Yes, I have opened it. I want to use this connector. Yes, it has different length. It has different lengths, but let's see if the price is okay and so on as well. And if we need to find a 90-degree version of it, because this needs to be here, and then it needs to be assembled here as a 90-degree connector, and then it should match to the bottom one. But let's see, the pitch is 1.27, and then I select that one. I just don't know actually. I tried to select everything. This LCS is not that good for filtering. They haven't at all they didn't add all these like parameters to the components. That's why all of them are not available, and it's sometimes difficult to find here. But number of two rows is 2, and then let's see. No, yeah, it is this one, green con. But do we have this actually 90-degree version? Or maybe we should check DGK. How is it going, guys, by the way? So you should just make some reactions that I can understand like if the stream is going good or not. And then we should check the backplane connector. No, not the backplane. It should be rectangular ones. Yeah, and then then it should be a board-to-board connectors. Yes, active in stock. It's like 5,000. But maybe we don't need to check in stock, so we need to just see the the pitch is 1.27, and then number of rows is 2. Yes, and then yeah, and then it's preferable if it is surface mount, but there's no right angle, unfortunately. Maybe that's not available. The stream is smoothie. Yes, thank you so much. But I can't find that one. Where was it? Was it Phonics contact? Where was it? Who had it? I forgot it. I don't speak Swedish, unfortunately, but I have to use the Swedish website. It's always like that. It just redirects me, unfortunately. Can I just select English? Yes. Yep. Products, connect board to board or cable and lines. So let's check. Yes, these ones. Yes. But do we have the 90-degree? Yes, it's here actually. Yes, we can see it. I want this one actually. So, because when I cover it with the shell, with the case, so I can just place it like this to the docking station. So yes, and the pitch should be 1.27. Apply, but product type, product family. But can we select? Show more filters. Type of no. Connector. No. But yeah, something like this, just the 90-degree version. Yep, this one is 90-degree. So yes, guys, we found it. I think I can use something like this. Yep, 90-degree. But probably like 12 pins would be okay. But this is 26. But let's just number of position like 10, 12, 16. Yep. Just let me close it again and then just try to find it. Yep, we have this one, nice. So we can put this one to the bottom board and then this one to the upper board. But we need to see the distance, if it is like good enough, if it can reach it. Do you know little Swedish? Yeah, I can understand like, but jag talar inte svenska. I don't speak Swedish. I know this one especially. That's so nice actually because everyone doesn't speak English. Yeah, usually most Swedish people do actually speak English very well, by the way. Yeah, this one would be nice, guys. So we can have this actually different height option for this one. I don't know if this one is changing in the height. Do we have this technical data? They don't have data sheet. It's so silly not to have it. But okay, so we found it actually. They have both available male and female, so this would be okay. Okay, guys, I think I can actually summarize like this, and then I can just pick the connector later, and then I can actually finalize the circuit. Just there is some small needs, some additions I need to do, and then let's check briefly. I need to actually change this one as well, and then this is almost done. This page, we just need to do some like cosmetics here. And the interface, as I said, I'm gonna just put the connector here, but not the PCIe, but that one. And screen side is okay. This circuit has already been tested actually in our one of module, so no need to do it again. And the power section, this is already tested as well. And then sensors, yes, we will need to check here once more. And this connection. So yes, guys, I think we are almost done for this time. But I hope we can see each other next week. So next week we should start with the PCB design. So we have finished this schematic now. So, but let me know if you have any questions before we end the stream. And then I will just close the stream actually. Programming part is a bit tricky, but let's see. Maybe not the whole programming part. I can do a bit, definitely, but not the whole. So maybe I can just prepare some small video and then I can show you how I'm doing it. But definitely, yes, we can do something. I will continue till the end because this is actually like this is going to be a product that we want to sell actually in our website. So that's why we need to finish. I need to finish it. Yes, guys. Have a nice evening, so to say, and then maybe see you in the next stream, which is next week. Next week Sunday. Sorry. Okay. Bye bye, and see you